Hello, everybody. We're going to talk about matter. Matter is anything that has mass and occupies space. So we would talk about matter, define it, and what is embedded in matter. What makes up everything around us? The answer is direct. Matter makes up everything around us. So we want to talk about atom, nucleus, proton, neutron, electron, element, isotope, compound, ion, ionic bond, covalent bond, and molecule. Substance is a form of matter that has a uniform and unchanging composition. So when you say something is a substance, the meaning is all of the matter that is embedded in it. It is the same, it's uniform, and it is not changing the composition. So it is the same, it is uniform, and the composition is not changing. Matter is anything that has mass and takes up space. So you have a table, then I'm putting a ball on this table. So the ball is a matter. The space on the table is being made smaller with the position of the table covered by the ball. So anything that has, and if you pull this ball on a weight balance, it's going to weigh something. So that means it has mass, which has been acted on by gravity, Newton per kg, and it also is taking up space. So atom, they are the building block of matter. The meaning is the matter you're talking about is made up of atoms are used to build the what? Build the matter. The structure of an atom are made up of smaller particles, which is called the neutrons, the protons, and the electrons. So the neutron and the protons, they are located at the center. So the meaning is you have a center, which we call the nucleus. So it is in this nucleus, we have the what? We have the neutron, and we have the what? The protons. They're all embedded in the nucleus. But the electron is revolving because there's a force of attraction between the electron and the what? And the proton. So it's wanted to move away, but it's been locked up and moving around all the time. So that's the reason they say the proton is positively charged particle. The neutron is said to have no charge. So there's no specific charge for the neutron. The structure of an atom, electrons are known to be negatively charged particles. So the negatively charged particles, which is why they wrote E negative, electrons constantly move around an atom. So they constantly move around around an atom. So this is something you need to understand very well. They move around an atom. So as I told you before, let's say, for example, this is an hydrogen atom. It's got one electron and it's got one proton with no neutron because it's neutral. Oxygen has got 8 electrons, 8 neutrons, and 8 protons. So the meaning is the number of electron is always equal to the number of proton, except the electron loses electron, or except the atom or the element lose electron or gain electron. If it gains electron, then it's going to increase the number of electron. If it gives electron out, then it's going to decrease the number of electron. All right? So this is exactly what happens. So an element is a pure substance that cannot be broken down into other substances by physical means. The meaning is you cannot break down element into something smaller than the way it is, because it is actually almost the smallest part of it. Elements are made up of only one type of atom. So this is not, it's not combination of atom. It's made up of only one type of atom. There are over 100 known elements, 92 which are occurring naturally. So there are over 100 known elements. Out of these 192 are naturally occurring, while the remaining 8 or more, they are being made, which means they're synthetic. They're synthetic, so they've been made. So each element has a unique name and symbol. Each element, they have a unique name. They also have a unique symbol. We're gonna see that in the periodic table. The periodic table of an element, they have a horizontal row, which is called a period. We have a vertical column, which is called a group. So this is a period. So elements in the same group have similar chemical and physical properties. Let's take, for example, 7, the halogens, which involves the chlorine, iodine, and fluorine. So all of these have the same chemical and physical properties. All right. And also the noble gases. The noble gases, they also belong to group 8. They have the same physical and chemical properties too, as you can see in the periodic table. So you can see this is halogens here. And these are the noble gases, helium, neon, argon, all of this. So they belong to the same group, so they have the same qualities. All right. So let's talk about isotopes. Isotopes usually happen when there is atom of the same element that have the same number of proton and electron. I told you before, the number of proton is most of the time equals to the number of electron, except it gains or loses electron. But they have a different number of neutrons. So the number of neutrons are different, and that's why we call them isotope. Let's give an example, carbon-12. Carbon-12 has got how many proton? 6. How many electron? 6. Carbon-13 has got 6 proton, but it's got 7. This is neutron. So it's got 7 neutron. And carbon-14 has got 6 proton, and it's got 8 neutron. So this is why we call them isotopes. So that would make the atomic numbers be the same, but atomic masses would be different. So this one is got 13 as atomic mass, and this has got 14 as atomic mass, because the number of neutrons are not the same. All right. Let's talk about radioactive isotopes. Changing the number of neutrons in an atom does not affect the charge. When you change the number of neutrons in an atom, the number of charge would not be affected, but it does affect the stability. So sometimes it's going to be very unstable. That is to say, it could break down easily. When a nucleus breaks apart, it gives off radiation. When it breaks apart, it gives off radiation. And this can be detected and used for many applications. So we can use that for many applications. Isotopes that give off radiation, we call them radioactive isotopes. Isotopes that give off radiation, we call them radioactive isotopes. All right. Okay. Compound, on the other hand, a compound is a pure substance formed when 2 or more different elements combine. So a compound is formed when 2 or more or different elements when they combine together. Compounds are always formed from a specific combination. What does that mean? We have H2O. It's a compound, which is water. So we form this water with two atoms of what? Of hydrogen, and one atom of what? Of oxygen. So that's the reason it gives what? Ratio 2 to what? To 1 for hydrogen to oxygen. So that's the reason it says it is formed in a specific ratio. Another example is carbon dioxide. It's formed with one atom of what? Of carbon, two atoms of what? Of oxygen. If you try to put C2O2, it's not going to give you this. If you try to put H2O2, it's going to be wrong. All right. So compounds cannot be broken down into smaller what? Compounds. You cannot break down compounds into smaller compounds. All right. So, or elements by physical means. So you cannot use a physical means for it, but they can be broken down by chemical means. So when you use a chemical means, it could break it down easily. All right. So compounds such as water are formed when two or more substances combine together. The force that holds the substances together is called a chemical bond. So the bond that holds them together is chemical bond. Electrons travel around the nucleus of an atom in areas called energy level. So that's the reason you see the cloudy area around the nucleus, which is where the electrons travel around. We call that energy level. Atoms become more stable by losing electrons or attracting electrons from other atoms. So if they want to be more stable, they will either lose or gain more. So an atom that has lost or gained one or more electron is called an ion. So ions carry electric charge, either positive or negative. The ionic bond is an electrical attraction between two oppositely charged atoms, for example, sodium and chlorine. Sodium has got one valence electron, one electron in the outermost shell, and chlorine has got 17 electrons, so it's going to transfer one, and it becomes what? It becomes 18 electrons, but 17 proton. And this one will have 10 electrons, and this will have 18 electrons because it transferred one electron to the other one. So this kind of bond is called ionic bond when there is an electric attraction between two oppositely charged atoms. So the chemical bond that forms when electrons are shared is called a covalent bond. In this case, there is no transfer, it's a sharing of electrons. A molecule is a compound in which the atoms are held together by covalent bond. So when you want to form a molecule, the meaning is they are held together, they're combined together by what? By covalent bond. So which describe the particle or particles that are in nucleus of an atom. So in the nucleus of an atom, which I told you before, we have neutron and we have what? Proton. So which is the answer? Neutron and proton. Which process changes a chlorine atom into chloride ion? Chlorine has 17 electrons. So when it gains one more electron, it becomes chloride ion. So what do we call this process? Electron what? Electron gain. How do the isotopes of hydrogen differ? They only differ in the number of what? In the number of neutrons. Okay? Which of these is a pure substance that cannot be broken down by chemical reaction? An element can never be broken down further. So this is the only one. All right, this marks the end of our reaction. Thank you very much for listening.